Hello everybody, Earth.Otherwise here to continue our journey into game programming in C++, start to finish by Eric Yuzwa. Right on the heels of all that math is the thing the math was for. In Chapter 6, which is actually titled Creating an OpenGL Renderer, the book will attempt to give us an overview of OpenGL, introduce the basics of creating and using an OpenGL context, introduce the OpenGL internal state machine, introduce rendering primitives, basic texture mapping, provide information on how to use display lists, render text, and finally introducing how to add fog effects to our scene. Likely it will fail to do most of this. As I've mentioned before, this book is quite old and several OpenGL updates behind. However, we shall press on, and with the help of Making Games with Ben and newer guides and some good old ingenuity, we can attempt to get on with the lessons in a relatively prompt fashion. OpenGL is cross-platform. It's made to be such, and it's the reason we're using it. At the time of the book's writing, OpenGL 2.0 had just been released. At the time of this post, we currently sit at OpenGL 4.6, though most of the code I know about was created under OpenGL 3.5, though so far it all still works and is not depreciated, unlike the code used in the book. Now, you should understand that OpenGL is fairly low level, much like C++ itself. You don't have access to things like simple full model rendering or quick texture mapping in a single line of code, as far as I know. OpenGL has the tools that you can use to create these things, but it does not provide them for you, nor does it provide an easy way to access inputs or manipulate application windows, as far as I know. SDL will handle that for most of us. The Peon engine has a class called Scene Renderer, which acts as a buffer between our game and OpenGL. We will likely have to create something similar in order to render to our window. Though this shouldn't be a problem, we are still well within the realm of things that others have covered over and over. Now, when rendering, you usually have two surfaces, the front and back screen buffer. You draw to the back buffer and you display the front buffer. When you're done drawing, you swap buffers so that you draw the entire new screen at once. If you were to, say, only have one buffer, then you would have to draw in the new scene on top of the old scene. This would cause bits of the new scene to be displayed on the upper half of the screen as the screen refreshes, with the old scene displayed in the bottom half, which is called tearing. This happens because rendering a scene takes longer than simply swapping a buffer. Even if your game runs at a solid 60 frames per second, you'll probably still have tearing issues if you tried to render directly to the front buffer. There is also such a thing as a triple buffer, where you draw on the back screen, display the front screen, and there's a third screen in the middle, and you rotate your screens forward. This can be useful because, in theory, rendering the screen is the last thing you do in your game loop, meaning if you've finished rendering but there's still a few fractions of a second before the correct timing to swap the buffers, that computing power in those microseconds is lost. However, currently not all graphics hardware is set up to be able to use triple buffering, though we might do some experimenting with it in the future. Of course, once we're done displaying, aka our game ends, or changes state to, say, a main menu or main game, we want to clean up everything we were using to create our graphics so that we can use that memory for other stuff. So, in the next video, we're going to create our own classes and ways to render some basic 2D stuff on screen. We're going to make a background color, render a triangle, give that triangle a texture, maybe make it a square rather than a triangle, do some work with MIP mapping and texels, probably. Then we'll do a little text rendering followed by simple display lists. Really, as this list of things continues, I'm starting to think that this should have been multiple chapters. Furthermore, we get to render a simple cube later, So we get to go from rendering literally nothing to a 3D object in a single chapter. Finally, we'll do some fog effects. Then we might do a little optimization, like minimizing state changes to OpenGL. Maybe change the color of the fog just because we can. Oh boy, this is going to be a long one. One step at a time, I guess. Join me next time as we create a color in our window. This has been Earth.Otherwise. Thank you for watching.